Hello my dear students, I think some of the questions are left to be done in chapter 5 and mainly the exercise problems that should be done in the class. And the first question is question number 8. You see, use the binomial theorem to prove this quantity. This equation this identity we need to prove using the binomial theorem. So first of all you should know what is binomial theorem, and I think you all know this. So binomial theorem, bi means 2, means here should be two variables, x plus y whole raised to the power n equal to summation running from k equal to 0 to n x raised to the power n minus k y raised to the power k, and that will be just multiply with nck, nck. Here notation is like this, so don't be confused with it. It is nothing but nck, what you generally use. Okay, so we need to prove this one. Okay, I want 2 raised to the power n in the LHS, and in the RHS I want this. So you see, try to figure it out. So you want x plus y is equal to 2. Okay, you want x plus y equal to 2 if you compare, because you need to prove this one, 2 raised to the power n equal to summation running from k equal to 0 to n nck minus 1 raised to the power k 3 raised to the power n minus k. This is you should prove this one. So you see, if you compare these two first, let me compare these two. Okay, so out of this I came to know that x plus y should be equal to 2. Okay, and here if I compare the you see here power is n minus k. N minus k is power of this, and it is the power of x, means x should be 3, isn't it? Can you compare it? Isn't it? So it implies that value of x is nothing but 3. Okay, and if I substitute value of x here, you will get y equal to minus 1, isn't it? So just you need to substitute x equal to 3 and y equal to minus 1 in binomial theorem. बाइनोमियल थ्योरम में x इक्वल टू 3 और y इक्वल टू -1 सब्सटीट्यूट करना है. तो लेट्स सब्सटीट्यूट इट. So if I substitute here x equal to, you see here, x equal to 3 and y equal to -3, it will -1. So 3 plus -1 whole raised to the power n equal to summation will go from running from k equal to 0 to n nck x raised to the power, x is 3, so 3 raised to the power n minus k, and y is -1 raised to the power k. So you see it becomes 2 raised to the power n, isn't it? And then equal to k equal to 0 to n nck -1 raised to the power k and 3 raised to the power n minus k. So this is the identity what we want. So it is hence proved. Okay, I hope you all understand. If you have any single doubt you can comment. Okay, अब ज़रा इस क्वेश्चन को देखते हैं. क्वेश्चन नंबर 15 ये क्या कह रहा है? It is saying that we need to prove for every integer n greater than 1, nc1 minus twice of nc2 plus nc3, it will go up to -1 raised to the power n minus 1 n ncn equal to 0. That I want. Okay, so how will prove this? इसके लिए आपको एक आइडेंटिटी याद होगी. पहले तो बाइनोमियल थ्योरम से देख लेते हैं. x plus y whole raised to the power n equal to summation running from k equal to 0 to n nck x raised to the power n minus k y raised to the power k. यहाँ से एक आइडेंटिटी आपको मिलती है. कौन सी? 1 plus x raised to the power n equal to summation running from k equal to 0 to n nck x raised to the power k. याद है कि नहीं? How we will got this identity from this? कैसे मिला था ये आइडेंटिटी? आफ्टर सब्सटीट्यूटिंग y इक्वल टू x इक्वल टू 1 सब्सटीट्यूट किया था, एंड देन वट एवर द रिजल्ट आई वॉज गेटिंग आई हैव रिप्लेस्ड y बाई x, ठीक है, y को x से रिप्लेस कर देंगे तो हमारे पास ये आइडेंटिटी बन जाएगी, ठीक है. ओके, सो हियर इफ यू नोटिस, if I suppose I take x equal to if let's take x equal to minus x, let's replace x tends to minus x. Okay, then what I will get? 1 minus x raised to the power n, isn't it? Then summation running from k equal to 0 to n ck minus 1 raised to the power minus x raised to the power k. Is it okay? Is it okay, everyone? So now next step is to differentiate it. Differentiate it with respect to x. If I differentiate this with respect to x, okay, let me know what I will get. So it will be, isn't it, n minus n 1 minus x raised to the power n minus 1, isn't it? Because if I apply, first I will differentiate 1 minus x whole raised to by n, so it will be n 1 minus x raised to by n minus 1. Then I will differentiate 1 minus x with respect to x, I will get minus 1, so minus 1 is multiply with it, so we'll have this, okay, equal to, in the RHS it is k equal to 0 to n ck, and here it is minus, you can take like this, can you, minus 1, here you can write like this, k equal to 0 to n ck minus 1 raised to the power k and x raised to the power k. Can I write like this? Yeah. So after and now I am going to differentiate this one, so it will be k into x raised to by k minus 1, isn't it? Okay, is it okay? So next step is to substitute x equal to, let x equal to 1. If I substitute x equal to 1, what I will get in the left side, you see, 1 minus 1, that will be 0, isn't it? Yeah. Summation k equal to 0 to n ck minus 1 raised to the power n k and 1 raised to the power k minus 1. So finally you will have 0 equal to summation running from k equal to 0 to n ck minus 1 raised to the power n multiply by k. Now let's check out the problem. So I have written this statement, here, you see, here. From here let me expand this. If I substitute k equal to 0, this will be 0, multiply this, it will be 0. If k equal to 1, I will have nc1, and k equal to 1, it will be negative of this quantity, okay, isn't it? Then plus nc2 multiply by 2 minus nc3 multiply by 3, and so on to, it will go up to plus minus 1 raised to the power, you see, n, okay, dot n ncn equal to 0, okay. So if I multiply it with again the minus 1, so you will have the same result, nc1 minus nc2 multiply by 2 plus nc3 multiply by 3 minus dot 2. Here you see, either it can be n minus 1 or n plus 1, both will be same. Let's take it n minus 1, so n ncn equal to 0 to compare with our result. So I hope this is also get proved, okay. One thing here, it is a mistake, it should be k, okay, यहाँ पे k आएगा, because आप देखो minus 1 raised to the k here है, so here also minus 1 raised to the power k, here also minus 1 raised to the k, ठीक है. बाकी ऊपर तो सही लिखा है, here it is written correctly, लेकिन फिर भी यहाँ तो k सही है, ठीक है. Now एक one thing I like to discuss with you कि मेरे माइंड में क्या आया कि मैंने इसको डिफरेंशिएट किया. वाई आई हैव डिफरेंशिएट दिस, इस टर्म को मैंने डिफरेंशिएट क्यों किया? बिकॉज हियर यू सी minus 1 raised to the power n minus 1 is there, and also n is multiplied, ठीक है, n यहाँ मल्टीप्लाई कब आएगा, x रेज टू द पावर n है, n मल्टीप्लिकेशन में कब आएगा, जब हम डिफ्रेंशिएट करते हैं, इजंट इट। तो n इंटू एक्स रेज टू n माइनस 1 आ गया। तो नेक्स्ट क्वेश्चन पे ज़रा फोकस करना, ठीक है। यू सी हियर, यहाँ पे मल्टीप्लिकेशन में n नहीं है, यहाँ मल्टीप्लिकेशन में 1 अपॉन n प्लस 1 है। तो ज़रा मुझे बताओ कि x रेज टू द पावर n के साथ मैं क्या ऑपरेशन करूं कि मुझे 1 अपॉन n प्लस 1 की फॉर्म में कुछ मिल जाए, मीन्स कोफिशिएंट 1 अपॉन n प्लस 1 हो। तो सिंपल सी बात है, आप क्या करोगे, इसको इंटीग्रेट करोगे सो दैट इट विल बिकम n प्लस 1, इजंट इट। सो इस तरीके से सोचा जा सकता है कि ये किस तरीके से फॉर्म बना है। ओके, सो एक क्वेश्चन 18 इज कि इवेल्युएट दिस सम, वी नीड टू इवेल्युएट एंड नीड टू फाइंड व्हाट विल बी इट्स वैल्यू। ओके, और साथ ही साथ यहाँ ध्यान दो कि यहाँ अल्टरनेट साइन पॉजिटिव नेगेटिव चल रहा है। इसका मतलब ये है कि एक टर्म आपका x अगर पॉजिटिव है तो दूसरा y कुछ ना कुछ मैं नेगेटिव लूँगा, तभी अल्टरनेट साइन चलेगा, इजंट इट। तो ये सब चीज़ों को क्वेश्चन देखकर ही विजुअलाइज हो जाना चाहिए आपको। ओके, सो चलो इसको शुरुआत करते हैं सॉल्व करने के लिए। तो आपको पता है कि x प्लस वाई होल रेज टू द पावर n इज़ नथिंग बट समेशन रनिंग फ्रॉम k इक्वल टू 0 टू n सी के x रेज टू द पावर n माइनस k y रेज टू पाई k। ये यूजुअली आपके पास होता है, बट आपको पता होगा कि मैं इसको इस तरीके से भी लिख सकता हूँ, x प्लस वाई होल रेज टू द पावर n इक्वल टू समेशन रनिंग फ्रॉम k इक्वल टू 0 टू n सी के। अगर मैं इसकी पावर चेंज कर दूँ, मीन्स x रेज टू द पावर k एंड y रेज टू पावर n माइनस k लिख दूँ, तो भी कोई ज़्यादा फर्क नहीं पड़ता है, इजंट इट। बिकॉज x प्लस वाई होल स्क्वायर इज नथिंग बट इट इज़ ऑल्सो इक्वल टू y प्लस एक्स होल स्क्वायर, इजंट इट। ये दोनों सेम ही होते हैं, तो इसकी पावर इसको दे दो या इसकी पावर इसके दे दो, दिस विल बी सेम, इजंट इट। So what I will do now, since here you see alternate sign is there, okay, plus minus you see, so let me take y equal to minus 1. If I take y equal to minus 1, what I will have is x minus 1 whole raised to the power n equal to summation running from k equal to 0 to n c k x raised to the power k, y means minus 1 raised to the power n minus k, isn't it? And is it okay? Now let's come to this part, this one. Let's come to this part, okay? So y, when it will come, if I integrate the equation. So let me integrate this with respect to x, okay? So if I integrate it, what I will get, you see, x minus 1 raised to the power n plus 1 upon n plus 1, isn't it? Am I right? Equal to summation will running from k equal to 0 to n c k, and here I will integrate with respect to x. So if I integrate x raised to the power k with respect to x, it will be x raised to the power k plus 1 upon k plus 1. Okay, then minus 1 raised to the power n minus k plus constant of integration. Now we need to find the value of this c also. For finding the value of c, what I will do, I will substitute x equal to 0. For finding value of c, I will substitute x equal to 0. So what I will get from here, it will be minus 1 raised to the power n plus 1 upon n plus 1 equal to, this whole quantity will be 0, isn't it? Because x is 0, plus c. So it implies the value of c is minus 1 raised to the power n plus 1 upon n plus 1. So let's substitute this value c here. Okay, so what I will have, let me write this quantity, this one here. Okay, so what I will have, summation running from k equal to 0 to n c k x raised to the power k plus 1 upon k plus 1 minus 1 raised to the power n minus k equal to So equal to and equal to, this term is there, x minus 1 whole raised to the power n plus 1 upon n plus 1, and this is here plus, so it will go in the left, means here in right, so it will be minus c. C is nothing but minus 1 raised to the power n plus 1 upon n plus 1. Can you get this? So finally we have, you see, you can write like this, x minus 1 raised to the power n plus 1 minus minus 1 raised to the power n plus 1 upon n plus 1. Okay, n plus 1 it is. Okay, so if I see the question what we need to evaluate, there is no x here. So there is no x, means let's take the value of x equal to 1 in the final equation what we have. So if I take x equal to 1 here, let's take x equal to 1, then what will have, you see, if x equal to 1, I have summation running from k equal to 0 to n ck 1 raised to the power 1 k plus 1 and minus 1 raised to the power n minus k equal to, here k x, I will substitute x equal to 1, so 1 minus 1 raised to the power n plus 1, this quantity will be 0. So 0 minus minus 1 raised to the power n plus 1 upon n plus 1, isn't it? Yeah. Now the next step is, let's see what I can write. Can this minus 1 raised to the power n minus k, so can I write like this, equal to minus 1 raised to the power n dot minus 1 raised to the power k, because minus raised to the power minus k is also same as minus 1 raised to the power k, isn't it? Yeah, yes. So I will write this like this. Okay, and also this quantity is nothing but minus 1 raised to the power n, or you can say minus 1 raised to the power n plus 2. So minus 1 raised to the power n or minus 1 raised to the power n plus 2, both are same, isn't it? So I am writing minus 1 raised to the power n upon n plus 1. So here it is already minus 1 raised to the power n, and here also minus 1 raised to the power n. This 2 will be cancelled out and we left with 1 also. And here minus 1 raised to the power k I will write as a, you see, 0 to n ck minus 1 raised to the power k I will write, and then upon k plus 1. Okay, equal to, let me write to make you understand. So here it will be minus 1 raised to the power n upon n plus 1. So you see here you can cancel out these two, it will be the both same quantity. So finally you will have summation k equal to 0 to n ck minus 1 raised to the power k upon k plus 1 equal to 1 upon n plus 1. So this is your final answer of this question. So your evaluation, the evaluation of this is 1 upon n plus 1. So you can check out by substituting value of k here. So if k is equal to 0, you will have nc0, then k equal to 1, you will have minus half nc1, okay, plus k equal to 2, it will be 1 by 3 nc2 minus 1 by 4 nc3 plus dot dot dot, it will go up to minus 1 raised to the power n upon n plus 1 ncn. Okay, that will equal to 1 upon n plus 1. You can compare this with your question. You see this one. Okay, so your final answer is 1 upon n plus 1 is the correct answer of this sum. वीडियो लेंथी हो गया है, तो इस क्वेश्चन को हम नेक्स्ट वीडियो के लिए छोड़ देते हैं. ठीक है.